Thanks, everyone. Can everybody hear me okay? Yeah, thank you for joining me for Rethinking Syncing. I did not know before coming here that that was going to be a problem with some people, because I was speaking to Johannes at dinner the other night, and he said, so you're talking, this is a philosophical talk, right? And I'm like, no, it's about data syncing. And he's like, oh no, this is rethinking thinking. So we're not rethinking how to think, we're rethinking how to move data around. So let's get into this. First off, what do I mean by syncing? Because this can mean a lot of stuff, like let's synchronize our watches, or there's a lot of different definitions of the word syncing. So what I'm talking about today is how I get data from my cloud, my server, my whatever representation is not on my device, to my device, and then how to get the data that I create on my device off my device so that it's somewhere else and safe where other people can see it. So that's the topic that we're talking about today. How many people have done this kind of thing in an app, a mobile app? Everybody, cool. All right. How many people have done it just kind of like the one way where you're just pulling data down to display? A few of us. And then how many have actually created data that they needed to send up? So everybody here. All right. So we've all had the same amount of fun. All right. So the way that I'm going to talk about this today is I'll break syncing up into two different pieces, right? So the first piece is really just the downstream effect. So I've got data out there, and I want to pull it down so I can show it. And then we'll break that up into the upstream effect. So I've created the data on my device, and now I want to send it back up to the server. So we'll take a look at syncing from those two perspectives as we talk through this today. Now, as we're talking about syncing, everybody here has probably dealt with a lot of these questions, right? So things you need to think about when you're doing syncing is like, how much data do you have to deal with? And that can drive some of the decisions you make as to how you build your syncing approach. When does the user want to see the data? Or how often do they want to see it? How do they want to use that data? That factors into your architectural decisions that you make when you're doing syncing. How much or how often does that data change? That can be an important factor that you need to think about. And then the key factor for a lot of apps is whether offline access is needed. And I would argue that for a lot of apps, you probably need offline access more than you think that you do, just for having a really good user experience, right? When you're interacting with your data directly on the device and not having any asynchronous processes or any waiting, that tends to be a much better experience for your users. All right, so I saw a lot of hands. Does everybody here that's done syncing used REST or REST-like APIs to do their syncing? A lot of those. Has anybody else used another approach, something different than just using APIs? Got a couple of hands there. Cool. I'm curious what you guys have used. Ah, cool. Okay. Cool. So somebody over there? CouchDB? Cool. Okay. Right on. All right. So I'm going to talk about sort of the gold standard of syncing first. So the stuff we've all done with REST APIs or REST-like APIs. And then we'll talk about actually Couch or Firebase, that type of solution next for how you can deal with syncing. So all right, everybody knows REST, right? If you do a GET for an entity with nothing, maybe you get a list. If you do a GET with an ID, maybe you get a single entity. You do puts and posts to do your adds and your changes, and then you can do deletes, right? So this is kind of standard REST, right? Now, when you're trying to get data to the device, I've seen a bunch of different approaches with REST or REST-like type of approaches to get data to the device. The first one is sort of the everything approach, and this is where your server isn't very smart, and for whatever reason, that can be you just didn't have time to build it in the schedule, you're taking an existing web server, you're dealing with a third-party service. So there might be a number of reasons why you have to go with this approach. And this approach ends up being, well, I just suck everything down, and then I ingest it, and then I just display what I need to display. And then the next time I need to get an update, I pull everything down again, I wipe out everything that I had, and I do it again. And that's pretty inefficient. It's kind of a terrible approach, right? The next is the net change approach. We'll talk about that in a little bit more detail, but that's probably one of the more efficient approach, right? Where you take, your server actually keeps track of your adds, your changes, and your deletes to all your data, and then is able to communicate those to the device from a known point in time. So that ends up being a very efficient approach. Then there's the kinda, sorta, but not really net change approach, and I realize I forgot to start my timer so that I know when to stop and take questions. We're gonna do that real quick. Thank you. So the kind of sort of not really change approach, I've just done this on a recent project with a client where They could do the adds and the changes, but they couldn't tell me the deletes. And this was just because they didn't have time in the schedule to update their server to be able to handle that, since it was dealing with a web-based application front end instead of our mobile front end. So what they told me was, all right, we can send you the adds and the changes, but for deletes, we don't really know. So we're just going to send you all the IDs in the database and you sort it out. Awesome. Thanks. Has anybody else had to do with do the kind of sort of not really approach before? Yeah, got a few hands. some smiles like that was joy, wasn't it? Right. And then last but not least is the as needed approach. This is a little bit closer to like the web-based approach, right? Where you're just like, I need to see this page of data, and then I'm going to select something and see a detail item. And you really don't need to sync all the data that's behind it. You really only want to see what the user wants to, or you really only want to show what the user asks for at a given point in time. So that's the as needed approach, where you just sync data as you need it. That tends to assume that you're online all the time when you do that. All right. So those are some two device syncing approaches. Now I'm going to talk about why I got in my mind to think about a different way about syncing, which is let's go through the net change approach and all the code that we have to write to get net change syncing done. All right. So here's our net change. I got some stuff on my device. I'm going to tell the server, hey, give me everything since November 2nd. And of course, I would have a bigger timestamp, but then it was getting too small. So I could be a little more precise there. And the server will figure out the changes, and it'll send me those. That's great. Okay. So the net change approach typically updates data from a known point in time. Like I said, this is the more efficient implementation of doing syncing using REST, but it does require more complex logic on both your server and your client. It uses less network bandwidth, but you do need to figure out on your server, you need to be able to track your adds, changes, and your deletes. And like I mentioned with this previous client, if you can't do that, then you have to sort of fall back to an ickier solution. You need to be able to track all those, and you need to be able to send them at a given point in time and be able to figure out what that set of data is, what those changes are. And then when you receive those changes on the client, you need to be able to process them so that what you have on the server now matches what you've got on the client. So there's a little bit of logic that's required on both ends there to make it all work. Now this is all pretty well-paved territory. We're all pretty good at this, right? But if you're building it from scratch, it can be kind of a hassle, right? And then last but not least, I want to mention that this always requires one source of truth for the since parameter. I don't know if anybody's done this where you've had two sources of truth or multiple sources of truth, right? Where you've got the server saying one thing and every device is saying another thing, and you end up losing some data here and there. Yeah, Neil's just rubbing his brow like, yeah, we did that. Yeah. Yeah, so if you are currently doing that, use one source of truth, please. It will save you some pain later. All right, so let's talk through the process of how we do net change. Now, in the example that I was showing, I had a little app or a device that showed red bars, green bars, and blue bars. So let's say, for example, we want to get net change for the bars that I've got on my device. So I would make a series of API calls, or if I'm lucky, I do a not REST process, and I make one call to say, give me all my changes for red, green, and blue, please. Or I might just have to make calls for each of those independently and say, give me the changes that have happened to my red, green, and blue bars. Now on the device, I'm going to iterate through each of those, and I'm going to perform those add, change, and delete operations to my local data store, right? And then I'm going to update the UI as each of those things happens. So that's not terrible. We've all done this before. But let's go through some of the code that makes all that work. So the first for each of these, I can write this nice generic function that prepares my URL request in iOS. This isn't terribly complicated, right? I just send it some parameters that I might want to use and a URL that's my base URL. And I use my URL components and I build a nice URL request and I return that. Piece of cake. But there's still a little bit of code that I need to write, right? And then next up, I want to make my API call. And here I've got kind of a generic example of a way to do it by type. So if I've got an entity and I extend it, I can have a nice way to do that. A lot of the code I've seen, we actually write functions to do a call per entity per REST verb type, right? And so those start to add up quickly. But here, this is pretty simple. I'll pass in what I want. I'll pass a completion handler, maybe an error handler, just kind of a general way to do things. I'll grab my fetch request based on all the parameters that I've passed in, and then I'll check for errors. And there's two errors that I need to check for always, right? The first one is the NSURL session task error, which will tell me whether I can get to the internet or not, right? Whether my networking stack is working. If that fails, I want to report that error back and be able to deal with that appropriately with the user. Then I'm going to make hopefully my responses come back if that's not the case. And in this case, I've actually connected to the server, and I want to check my HTTP status code as well. So if that's not 200, something else probably failed, right? And I want to bail out there and tell my caller, hey, that didn't work either. So tell the user something's going on. And if all that works, then I'm going to get to my ingesting data. Okay. So again, this is not terribly complicated. People have done this. It's pretty basic stuff. But if you're going through each entity that you have that you need to do this for, and then a lot of those those REST verbs, this can add up. All right, so now let's ingest this data. And again, I'm not assuming any particular data store here, but this is all, again, simple, straightforward, boilerplate code. I do my JSON. I'm assuming we're getting JSON data back. And then I check it to make sure I get the payload that I expected. If not, I say invalid JSON. And then I try to ingest it into some model objects. And if that works, great. I tell my completion handler, hey, I've got some objects. If not, then I say, sorry, I couldn't ingest that JSON. It was bad. Let's bail out and tell the user. All right. So we've gone through that's kind of the general stack of code. And I haven't even done any of the UI updating or any of that kind of calls, right? So this is just 3 simple entities, right? And I've got all this code to do all that, right? And if you've written apps where you've got 20, 40 entities, this can start to add up really fast, right? You can get a lot of code. And your code can actually scale almost linearly with the number of entities you've got or the number of REST verbs that you're supporting per entity. So that's something to think about. And this is kind of what got me thinking about why can't we do this a different way? All right. So now let's talk about from device syncing. So I've created some data on my device, and now I want to get it back up to the server. I've done this on several different apps and experienced various degrees of pain with it. So there's a couple of different approaches that you can use to do this. The first is sort of the online-only approach, right? Where this is just, I'm not going to support anything difficult here. I'm going to make sure we're online, and I'm going to send my data. And then if it doesn't work, sorry, user, try again, right? And you're out of luck. That works for a developer. It's probably not the best experience for a user, right? If you've typed in a bunch of data and now you're telling the user, sorry, just because you're in a bad network condition, you can't keep your data. That's not really the best solution. All right, so the next one, the next 2 are pretty similar. There's the persist the network call approach. And so that's the kind of thing where you might have to install a third-party library to do this, where you create your network call to make your data save. And then if it doesn't work, it can save or persist that network call and then resurrect it later and then retry when the network conditions have improved. So that's an improvement, right? There are some complications with that where you start having, if you have dependencies or anything like that, that can get to be troublesome. And the last approach, that's sort of the most robust approach, is the offline first queue approach. And so I've built this a few times too, where the user creates some data on the device and you save that into core data or whatever your persistence solution is. And then you make a queue. And then you have a detector that picks up when data has been saved, and then it starts to process it. And if it fails, then it can update your queue and say, I need to retry this later when network conditions have improved, or when I've able to resolve a given error. And then you just work through that queue. And so that way, somebody can be off in the jungles of the Amazon taking pictures and making comments and all that kind of stuff. And then a week later, they can attach to the network and it'll all upload very nicely. So that ends up being the most robust and the best solution, but it can be a little bit of work depending on how many dependencies you've got to deal with. Go ahead. Absolutely, and that's the reason you do it, is you make sure that queue is persistent and it saves when the app gets killed, so that when you come back later, the queue is still there, right? And you haven't lost any data. That's the whole reason you do it. Yeah. All right, so I didn't even try to write sample code for this because I'm like, we've all done this too, right? There's a lot of code there. And as I've talked through it, everybody's like, yeah, that's a lot of code. Okay, now we've talked about that. Let's talk about some complications. So offline mode, we just talked about queuing uploads, right? That can be a little bit of work to get that all polished and right, especially in the middle of your development cycle and you've got issues with your server, and that can be kind of a hassle and can take some calendar time to sort of work through all that. The next one that I mentioned sort of briefly are dependencies, right? Because I've been talking about this with sort of the blatant assumption that we're only pulling one thing at a time and there's no, nothing depends on anything else, right? But I've worked on a number of projects where we need to fetch one entity. For example, if I have to fetch my order information to figure out what customers I need information about, and then I got to go fetch the customers, and then I got to go fetch the item information, that kind of stuff. So dependencies can be a complicating factor, and especially when you're uploading data. A recent app, the same one that I talked about doing offline, we wanted to be able to take a picture, capture some metadata about it, be able to comment on your own app or your own image that you just did offline, like your own image, edit your own image, add more metadata, do comments on that, and be able to do that offline until you were able to connect to the network. So being able to build all those dependencies and support them with your upload could be pretty complicated. So there was a lot of code and a lot of thinking that had to go into that kind of stuff. All right, and then last but not least, when you finish version 1, you're not done, right? Things always change. You always want to make improvements and new features and all that kind of stuff. So when you're changing your model, you need to end up syncing your API changes with your releases somehow, so maybe API versioning or something like that. And then you need to be able to support your older versions because you're not going to be able to do a big bang change every instance of your app in the world all at one time, right? So you either need to do API versioning or do non-destructive changes to your model objects, to your model, your API responses. And there's a number of ways you can deal with that, but it's all complicating factors, right? Anybody else tired? Yeah, I'm ready for a drink after all that. So, cool. Now, what if we didn't have to do that anymore? What if there was a way that we didn't have to write all that syncing code every time we do something like this, right? Well, it turns out there are a number of databases out there, new solutions that have come up in the last few years, and I'm terming them eventually consistent distributed databases. That's not the term any of them use. They'll use stuff like real-time database or engagement database or I don't even know what else database. But these types of solutions generally have 3 important pieces that matter. The first is there's a server database, right? So there's something on the server that you can put data in and pull it out of, and query and all that kind of stuff. The second piece is a sync server. So this is something that mediates between the cloud server and then all the mobile devices. And then the last piece is a mobile database of some kind. So a persistent solution that your mobile database can work with directly and support an offline mode. So there are a number of examples of this in the market today. Personally, I've built a couple of apps using Couchbase. There's Realm. I've investigated that a little bit and written some sort of sample stuff with that. I believe Firebase can do very similar things like this, and then AWS AppSync. And there may be others that I'm just not aware of. So I'm kind of curious, if anybody else has other examples, I'd love to hear about those as well. All right, so let's talk about the idea. Like, how does this type of solution help us alleviate all the whatnot that we had to do and makes us want to go to the bar? So there's a few different pieces here, and the top part of this diagram, this architecture diagram, is really what the offerings provide, right? So there's the server, a sync server, and then a local database. And then the bottom part is the custom stuff that you need to do. So let's talk about each of these sections in a little bit more detail. All right, the first piece here is the server side. So in this case, you would have, in this example for using Couchbase, for example, we have the Couchbase server. So that sits on the server, and that's a NoSQL database, so it hosts JSON documents, right? And so that's where all our cloud storage exists. And then what we would do is write services that sort of set what our state of data is in the Couchbase server. So the Couchbase server just represents what we want our model to be at any given time, right? Like what's our state of data at any given time. And so we just write services here that talk to any of our legacy data, any other data services to make that Couchbase server a picture of what we want our entire application data state to look like at any given time. Okay. So the next piece is the sync server, and that just has a simple job. If something changes over here, tell those people about it. If something changes over there, tell that about it. That's it. That's what it does. And the last piece is the local or mobile database that sits on your device inside your application. And then the way you architect your application is you talk to that database and that database only. You don't do any network calls. You're not aware that there is a network at all. You just talk to that database directly. So you ask that database, hey, what data do I have that I should display? Great, I'll display that now. I'd like to make an update to my data. I update the database. That's it, I'm done. And then it's that database's job to talk to the sync server. And you can know what the status of that replication is, but it's not really your job to deal with that, right? So you don't have to do all the queuing or any of that kind of stuff. It's that database's job to talk to the sync server and tell it what's different and tell you when things have changed that have come to it. All right, so that was all abstract stuff. Let's do a quick little demo. I'm not brave enough to do live code, so we're going to do video demos of stuff that I know actually works. So I built this little sample app just to sort of work through these concepts and give us a little bit of code to look at, right? So this is by no means good code. This is ugly demo code that just sort of explains the concepts. So this app, all it does is show some bars, right? So our green bars, our red bars, and our blue bars, and it's got some buttons that allow you to add and delete each of those colors. So I'm going to play this, and it'll add some buttons or add those bars, and then you can scroll around because we have more than are on the screen, and then we can delete those. And as that's happening, this is syncing with the server as it happens, right? So now we ended up with 10 bars because I added and deleted and changed some stuff, and that's what I ended up with. Let's take a look at what the server looks like after that all happens. So what I'm showing on the left-hand side here, that is the sync server. That's the Couchbase sync server. And this is actually all the data that's represented over there on the app. So each of those bars, I've got a UUID that just sort of represents the document. And so each document is just some JSON that represents a bar, okay? And so that could be representing any entity that you have in your app that you might show in a collection view or a table view or something like that. So then that top one up there that's selected, that starts with OA5, that's just a little bit of JSON that says I happen to be a green bar, I was added by my demo user, here's my ID, here's my last revision, that's a Couchbase thing, and then, you know, just some details that are in there as well, right? So that's how you can see that I've got 10 records in there, and those match up with all of the bars that I created in the demo app. All right, so now let's go back and think about that diagram, right? And now I'm going to add some data from the server, okay? So something changed over here in the world that's away from my mobile device, and I want to know about it, okay? So what I've done here is I've added a really simple API call, and I'm going to put some data into the server, okay? And this is going to be a red bar, and just watch very closely what happens. So the cursor will move over there and hit that refresh. So it's going to add this document to our sync server and our server, and then it's going to get reflected in the app because the app is tied to the sync server right now and is communicating with it. So watch closely. I hit that, and I watch it appear, and it happens almost instantaneously. So this is one of the great benefits of using a database like this, is if you use continuous syncing, you can be notified almost instantaneously and then react to those changes. All right, so let's just talk about what happened there with that demo. So the first piece is we've got when we added that document, you know, I just used a service to add that, right? So I just added it right in. The server got the document. The sync server said, hey, something changed. And since I was attached, the sync server said, okay, who needs to know about this? And since my app was attached to the sync server and syncing, it said, oh, I need to know about that. We got the new document, and then we notified the app, hey, the data that you were using to display has now changed. Update your user interface with the new data. All right, so how do we implement all that? We're going to go through model objects, data controller, fetching data for display, handling refresh on change, and then adding and deleting, because adding and changing are similar enough that they'll be the same. All right, so model objects. To build this sample app, I just had 3 model objects that are all really simple. They've only got 4 attributes each. They're just strings. These happen to be structs. So pretty simple, straightforward stuff. The key here is they're codable, right? People used codable in Swift before? Some people? Yeah. If you haven't, definitely look into it. It will save you a ton of time and effort. It's really nice. So these are all codable. So when I get JSON data, I just say, make me an object with this, and it does it magically. So, and what's also nice about codable is if your objects, because these are, a little trivial, right? I mean, nobody's making an app with just 4 attributes in their entities. Well, maybe you are, but I want to work on that app. Be much better. Some of these entities can get very complicated, right? And you can have dependencies and all that kind of stuff. And if you happen to have like nested, where my blue bar might contain an array of red bars and my red bar might contain an array of blue bars and that kind of stuff, those kind of relationships, you can actually represent those relationships in your JSON and have those handled automatically by codable. So if you set your documents in a way that sort of represents dependencies like that and makes sense for your requirements, stuff like that can be very, very easy to deal with because codable will handle it all for you automatically. And the same is true when you're updating and saving data. If you update and save data locally in your JSON, and you can use codable to put it back into a JSON structure, and then send it back through this pipe, that can be a lot easier than having to manage all those relationships and dependencies. All right, so that's the model object. The data controller is actually really simple. I just need to get a reference to my database. That's it. And then I need to set up my syncing, okay? So there's a couple of different factors that you need to do. Make sure you've got a database or else syncing doesn't work. Then you like to say what type of replication you want to do. So there's push, pull, or both. So push is really just sending data to the sync server. Pull is pulling data from the sync server. And then you can do both at the same time. There are reasons why you might want to do some of those separately. For example, the next piece here is continuous, whether you want to be attached to the sync server all the time that your app is active, say that 3 times fast. Or you just want to do a sync based on some user interaction. For example, if you do a pull to refresh and you're like, I want to sync now, but I don't want to be syncing all the time, right? Just because I'm going to hammer my server or, it's not a user requirement, that sort of thing. All right. So as we're talking about the push and pull, oops, I think I just screwed something up. There we go. So there may be valid use cases where you want to do a push separately from a pull, or be able to start those, instantiate those separately. So you can pick the way you want to do this, and you can actually have multiple replicators if you need to. All right, so we talked about that. We talked about continuous. You can have this be talking to the sync server all the time while the app is active, or you can just do sort of one shot at a time, where you're like, okay, I want to do a sync now, I want to do a sync later. You can do that in response to user activity, or you can do that just based on whatever your requirements are. And then the last piece here is I didn't show the code for this. It's only 5 or 10 lines of code here as well. If you want to listen to your replication and just know what's going on, am I trying to attach to the sync server? Am I pulling down data right now? Am I syncing? Did I finish syncing? That kind of stuff. You can set up listeners for that, and it's just a couple of lines of code. And then you can respond to those events as well, so that you can show your user, hey, I'm syncing, don't expect to have all your data right now. Or, hey, I finished syncing, you should expect to have all your data right now. And then here's the last time I synced, that sort of stuff. Okay, so that's the data controller. Now the next piece is fetching data for display. I apologize for the big chunk of code here, but this is actually pretty straightforward. So this is all stuff people have done from core data or other persistence sources. So this is some code that'll actually query the database. So that first piece is a query. And in Couchbase, they've got kind of a nice solution where if you know SQL or you're comfortable with SQL, their query builder is actually really, really similar to SQL. It works basically the same way. So you can build, a select, figure out what attributes you want from the database, and then in this case, I'm using, this is kind of a convention where you set a property or an attribute called type to say what your entity is that you're trying to pull from. And in this case, this is my green bar, for example. And then you can add additional where conditions, that talk to the attributes that you've got in your data model. So that's the query. So you just set up a query. And then the next step here that I'm doing is setting up a listener. And this is, has anybody done NSFetch results controllers in Core Data? A few people? Okay. So the benefit there is with Core Data, when you use an NSFetch results controller, it will tell you when the data has changed underneath the stuff that you've got going on, right? And so that way you can respond instantaneously and just update your user interface when things change. So this is not quite as nice as that, but it gets you pretty close. So here I've got a listener that I'm adding, and I'm just going to tell my data controller, hey, when stuff changes, call my refresh handler that I've already added. And I've just added this separately, and I'll show this in a second. And the next piece there is I'm executing my query, and I'm just ingesting that data, right? So instead of the results that I get from Couchbase, which are just JSON or a dictionary of information, I want to have those be my nice model objects, right? So I use my codable JSON serialization and just decode those objects. And of course, if we are in production code, I would genericize this and make it nice and neat and not all in the same method and all that kind of stuff. But this gives you the sort of the concept of all the stuff that we need to do for all this. Okay. All right, so next up is handling refresh on change. And this one I did a really, really simple example, right? So my refresh handler that I just set to my listener, so this just says, hey, data controller, when you're listening to my query and something changes, do that, okay? And all I'm doing there is refetching my query and then updating the section of the collection view to show me what's currently in there. Now you could be a little bit more fancy about that because the listener's got details on the changes. So you could do a lot of the stuff that an NSFetch results controller does, right? Where you can you could figure out your index paths and what you want to insert and what you want to pull out and all that kind of stuff. It just doesn't have all that built in yet. So you have to do a little bit of your own work to make that happen. But if this is sufficient, then you can get away with just a few lines of code to make this happen. All right, so adding data. I'm going to add a green bar now. So what I do here is I just check to make sure I've got a database to add it to. I create a Couchbase mutable document using the ID that I've generated. That's just a UUID. And then I encode that into JSON. And then I set that document's data to the JSON that I just encoded. And then I tell the database to save that document. And that's it. So that's pretty simple and straightforward. You'll notice I don't have any threading or queues in here, right? I'm not doing main context or background context or any of this kind of stuff. This is another nice benefit of Couchbase specifically is I don't have to worry about that stuff. I can just talk to it directly. I can do stuff in the background and then I can send my structs forward into the main context and not have problems. So that can be a nice feature as well. Last but not least is the deleting data. So I check to make sure I've got a database. I find the document that I want to delete. So I'm using my model object, right? And I've got an ID associated with that. So I just look that up in the database using this document with ID method. And then if I don't find it, well, now I've got a problem. I'm out of sync. Something went bad. But if I do find it, then I just delete it. And that's all there is to it. And so then I've updated that database. And if I happen to be attached to the sync server, it manages all that by itself. And I don't have to do any additional work to do my syncing. All right, so that was all the code that you need to do to get through the entire life cycle of adding data, pulling data down, syncing data, deleting data, displaying it on the screen. That was it. So let's talk about some of the advantages of this type of approach. Um, First and foremost is a significant simplification. Should reword that so it's a little easier to say. Of syncing code, because that's quite a mouthful of a sentence. So you just set up this database, set up the syncing call. That's kind of 10 or 20 lines of code. There are no API calls needed. I do have an asterisk there, which is, if you, depending on your method of authorization or authentication too, you may need to make an API call to, if you're getting a token or you're doing something else, you may need to do an API call to set that up. But if you're just using basic auth or something like that, you probably don't need to. Dependencies can be much easier to handle. As I talked about, if you've got nested relationships between entities, you can build those relationships into your JSON and have it handled automatically by Codable. And then lastly, there is thread safety, as I just mentioned. You can have a lot more flexibility with doing stuff in the background and then moving it to the foreground or the main queue to be able to display stuff in your UI. And you don't have to do the stuff like in Core Data, where if you're going to do a really big query in the background, where you get a bunch of Core Data objects and then you need to redo them on the main queue, right, so that you can display them in your user interface. So this can alleviate a lot of pain there. So there's I think, a significant simplification of the model and ingestion code. This model ended up being, compared to Core Data, is quite a bit simpler, right? It's just a whole lot easier to do. So you don't need to build a Core Data model. You don't need to set up all those, those relationships and stuff in your model diagram. You don't need to use mode generator to get the nice, translating your integer to ints and all that kind of stuff. So you don't need to do any of that kind of thing. And then the models can be classes or structs using Codable, like we talked about, and that's very simple to code, and that can save you a lot of work. And then the last piece here is the simplification of services. So we still have services in this idea, right? But the services job is really just to make the server side picture of the world be accurate. So it doesn't have to respond to every single entity. You don't have to have a service for every single entity or all that kind of stuff. You just need to get the server to be updated correctly, right? So it doesn't have to have the complexity of doing your net change, your adds, your changes, deletes, all that kind of stuff necessarily, if there's an easy way for you to be able to reflect it from your legacy services. And then on the device side, it's obviously a lot simpler, right? I don't need to write any code to handle my adds, change, and deletes to my local storage at all. Okay, now let's talk about some disadvantages of this. One of the ones we ran into, quite quickly was just a lack of familiarity, right? Like people just aren't used to this approach. There's a lot of stuff you sort of need to rethink for common use cases. So we ran into one issue which was rather painful, which is we had a database of about 100,000, 150,000 records of stuff that people would look at and approve. Well, in the middle of testing one day, and we're sort of, kind of crunch mode and, kind of really pounding on stuff, the client refreshed the source database from production, which was great. We needed nice fresh data to test with. But they wrote every single record in the database again, which then went through our sync server. And we didn't really expect that, or weren't really considering that as a potential thing to happen. So now we tried to sync every single record in the entire database when we should have only been syncing 10 or 20 records per user. So that kind of threw us for a loop there. And it sort of crushed our CB instance for a couple hours while it sorted through all that. So stuff like that where you don't really think about it ahead of time and you're like, ooh, yeah, that's bad. We can't do that anymore. Then the architecture also sort of requires different thinking for common use cases. So this example where we have a bunch of different stuff that people will look at, 10 things, and then they might approve it or say, no, I don't like that. Well, now how do you do that? Because right now, or with the REST API approach, if I'm going to approve a record or deny a record, I might just do that with a REST call and say, well, here's the ID of the thing I want to approve, send that up, it'll tell me right away whether that worked. Well, if I update that in Couchbase, and I update the data record, and then it syncs, how do I know if it worked or not, right? How do I know if there was an error? I don't know. So you have to figure out a flow, a syncing flow, to work through any of the workflows of stuff like that you're trying to do. So in this case, what we did is we added a special record to do an approval for something where we would put the ID in there, put our user information in there, put our timestamp. The server would notice that change get synced, pick it up, execute a service, and then update that same record to tell us whether it worked or not. And if it didn't work, it would give us an error message in there. And then once that synced, we would be able to pick that up and display it on the screen. So it's a little bit different than the typical model of using your REST API and then I get an error, I can now pass that through my completion handler, right? It doesn't work quite the same way. So you sort of have to rethink those common use cases that you're used to doing. Another kind of important piece here is you can't control the priority of syncing. So for example, let's say you've got 20 different entities and you've got one where you're like, I really got to get that one first. My 19 other ones, I don't really care about, but that one, I want to make sure that's synced first all the time, right? Well, with one syncing push and pull session, you can't do that. You cannot control your priority of that. Whereas with a REST API solution, you'd make that call first, right? Get your information and then be able to update stuff. So one way that you can approach this type of thing is you can have multiple replicators, right? You'd say one replicator would only pull stuff for that entity, right? And there's a term called channels that CouchDB or Couchbase uses to organize documents. So you'd have to come up with a scheme where you put all the high priority stuff in one channel, set up a sync for that, and then set up the lower priority stuff in a separate channel, and then set up a separate sync for that. So you could make sure the first sync happened and you were done before you even kicked off the separate sync, the second low priority sync. So that can be kind of a hassle there, but if you're not thinking about it ahead of time, you can really sort of wedge yourself and realize, ooh, I needed to do that stuff first and now I can't. So something to consider if you're going to look at a solution like this. And then the last piece is they're really, the listener's pretty close to what NS Fetch Results Controller will give you, but it's not quite as convenient. So if that's something that you're coming from, just be advised that you're going to have to write a little custom code to make that work the way that you're used to. Okay, so what are some of the best use cases for this type of approach? For us, what we found is it's really good at handling that slowly changing master data. So like the example from yesterday where the gentleman was talking about the rail schedule, right, in React Native. This is a great solution for stuff like that, right, where it's like, I need to know what my stations are, I need to know what my lines are, what my typical schedule is. And that data doesn't change all that often, but when it does, you want to make sure everybody has it right away, right? This is a perfect solution for that, where it's not a ton of data, and then you can just do a sync, like a one-time sync every time you run the app, and it can get that data for you. So that ends up being a really, really good solution for that. It's really, really good also for user-created data, and especially when you've got like dependencies and complex stuff there. It's really good at that kind of thing, right, where it'll just sync that up for you, and then you can write a really simple service on the back end to update it. My asterisk here is I don't think it's necessarily good for images, just because there's a lot of data in there. Couchbase does have a way to deal with blob data or binary data. I'm just not convinced it's the right way to go with something like this yet, or other types of data that have a lot of that are rather large. If you're dealing with sort of small records, it's really good for that. And then lastly, it's not ideal, I don't think, for large amounts of quickly changing data. So the example that I'm talking about that we wrote for a client, it has a lot of master sort of organizational data, but we also have stuff that changes, hourly, daily, and a lot of data that changes quite frequently, right? So the organizational data it's great at, but we don't want to sync like all of that data for all of our different permutations of all our organizational stuff, right? Because the user is not necessarily going to look at it every time. So what we decided to do was draw the line and say we use Couchbase for the organizational data, and then we use REST APIs for the as-needed quickly changing data. So that's where we drew the line for that. That's what I've got for rethinking syncing. I think we've got a moment for questions. Is that true?
Yes. Yeah.
Okay, great. So happy to take any questions.
If you have a question, I can ask them.
Yeah. Go ahead.
Do you have to deal with
Can you repeat the question?
So the question is, did we have to deal with conflict resolution? With the two apps that I worked on, we did not. Just because we were the only source of data, or the mobile device was the only source of data, so we really didn't have to deal with it. There are a couple of very simple approaches for dealing with it, but I don't know that it's ideal. So it's something that you want to investigate very closely before making a decision, I would say. Because you can either have it do sort of the last change wins approach, or you can have it just say, I failed. I have a conflict, it's your problem now, right? Yeah. Other questions? Nope. All right, well, I'm happy to talk about this with anybody else if anybody has more questions later. You can find me on Twitter here. And a big thank you to the organizers here at Mobile Air for putting on an excellent conference, and thank you all for attending. Appreciate it.